you have been using this formula in your daily calculations, guys, as far as science is concerned. But guys, have you ever wondered on how you can actually prove the formula? In this video, friends, today we shall be looking at how we can use calculus to prove that the volume of a sphere is given as 4/3 pi r cubed, where r radius of the sphere. So friends, please, if you're new to this channel, don't forget to hit that subscribe button looking at you and press the bell icon to get notified each time we have new videos, guys. And please give the video a thumbs up because it does motivate me to keep producing more great content for you. Thank you very much, guys, and let's dive straight into our video today. Perfect, guys, perfect. As always, guys, we shall try to picture our curve of this form. We shall call this the vertical axis, which has a name y. Then we now have the horizontal axis, guys. We shall call it x. Good. So we are now going to have a sphere of this form, but before then, guys, we have the sphere. As you can see here, guys, we have our sphere, which is in the form of a circle. Then our friends, here's the origin, and guys, this circle has a radius of r. Here we have r, and from the center, guys, from the center of the circle, that is at O, to the left we have negative r. Good. This is what we have. Then friends, the equation of this circle, as you all know, guys, whose radius is r, whose center is at the origin, it is x squared plus y squared equal to r squared. Good. So friends, I think we have everything said. Let's now dive straight into the main proof, guys. So in this case, guys, we are going to be using the disk method. Okay, we are going to be using the disk method. This is how it works, friends. We are going to keep cutting this our circle such that into pieces that are almost identically equal to each other. Okay, by that, guys, you see that we are going to produce a disk. We can simply get the volume of each disk, because you can get the volume of a disk, right, which is simply going to be pi times the radius squared times the height. Great. Pi times radius squared times the height. That's it, guys. Then we are going to sum up all of those disks. It is going to give us the volume of our entire sphere. Great. So guys, like I said, we are going to split, or we subdivide this our sphere into identical disk. Great, friends, and let's subdivide, guys. We have just these few divisions here, and friends, we are going to call each of these divisions, they are going to have some small thickness or change in the x values as delta x. Great. We have here to be changed in x. Great. Then friends, we are now going to be seeing that the volume of each of these disks that we are going to form now is going to be v, which is going to be approximately equal to pi y squared times the thickness. Guys, keep in mind that our y in this, our radius, the radius of each disk, guys, the radius of each disk in this case is simply going to be y. Okay, simply going to be y. Good. Then friends, all we are going to do now is that for the whole sphere, right, we are going to sum up all of these our disks starting from minus r. Okay, because the disks are going to be from minus r, that is the smallest, up to the biggest, which is r. So we are going to keep cutting everything, and we are going to be summing up everything such that the sum of all of the disks that we are going to produce by cutting our sphere into this smaller disk is going to give us the weight, is going to give us the volume of our entire sphere. Great. So it's going to just be the sum from negative r to r of all the volumes. Okay, the volumes of all the disk we are going to produce. Great. So now, guys, we are now going to change from this continuous to now a disk. Great. So we are now going to be having our v to be the same like now the definite integral going from negative r to r of pi y squared dx. Great. But friends, pi is a constant, we can put it out of the integral, so we now have pi times the integral of negative r to r of y squared dx. But friends, y and x cannot exist in the integral. Okay, they cannot exist, so we have to isolate one of them. In this case, guys, we can only isolate y. Okay, because we have the equation of the circle to be x squared plus y squared equals r squared. So friends, we make y the subject, we are going to have y. By sending x to the right hand side, we have y squared to be the same like r squared minus x squared. Good. So our integral now turns out to be the integral. We have pi times the integral from negative r to r. Our y squared is simply going to be r squared minus x squared dx squared. Everything is in terms of x now. We are good to integrate. But friends, to make things easy for ourselves, we can use one of the properties we all know of definite integrals, right? that if we are integrating from negative of some value to the positive of that same value, guys, of a function, as long as that function is an even function, we can therefore use our knowledge of even functions that the graphs of all even functions are symmetrical about the line x equal to 0 or the y-axis squared. So guys, the integral going from a negative value to the positive of that same value of an even function is simply going to be what, guys? 2 times that same integral, now going from 0 to r of simply r squared minus x squared dx squared. So friends, this we have simply applied our properties of definite integrals, and most especially, guys, of even functions, as we all know. Great. So guys, as we have this now, all we need to do now is just to integrate. Integrating r squared in the x world, guys, we are just going to multiply it by x. We are going to have our 2 pi is outside. We have our 2 pi which is outside. Then we have r squared x minus 1/3 x cubed. The limits of integrations, guys, are going to be going from 0 now, and they'll be ending at r. Good. That's what we have. Then friends, substituting all the values, we are going to have when x takes r, we are going to have r squared, we have r minus 1/3 r cubed, minus putting everything to be 0, we have minus 0. Good. So friends, if we simplify the interior of this our brackets, we are simply going to have 2 pi outside. Then inside we have r cubed minus 1/3 r cubed. If we simplify further, we are going to have 2 pi outside. Then inside we have 3 r cubed minus r cubed, which gives us 2 r cubed over 3. 2 pi times 2, guys, simply gives us our answer as we have it to be 4/3 pi r cubed, as required, guys, as required. So friends, that's how we can show that the volume of our sphere is as we have. So friends, please, if there's something you didn't understand, friends, it is my pleasure to understand to the least. Okay, it's my pleasure to make you understand everything that this video is presenting. So friends, put your worries in the comment section down below, and I'm going to reply to it as soon as possible. Thank you very much, guys, and don't forget to like the video, friends. Please subscribe to the channel if you want more great content. Thank you very much, and have a blessed day.